Thanks. It's always nice to get an applause even before the presentation. Always feels good. So yeah, really nice to see so many faces here in this room for everyone to learn together with me about dataset enrichment using LLMs. So you can actually see it says 27th. Well, it is of course the 30th of November, and I hope still everyone has enough attention left right before the lunch. So that's for me the challenge to bring it in a nice way. So what about me? I'm Jeroen Overschie. I'm a machine learning engineer at PyData, and what we do is we go to companies and we help the companies bring their machine learning products into production, and also make sure that they stay into production. So that is what we do as a company, and as a day-to-day, I work as a machine learning engineer, sometimes as a data scientist. So you're all here to learn also about LLMs. And LLMs are booming. So many people talk about it these days, and you hear so many things about it, also in the news. And so why is that? Well, we can see ChatGPT got launched. It took ChatGPT only 5 days to acquire 1 million users. And that is really, really super fast. Because if we compare it to some other services like Instagram and Spotify, Instagram took 75 days, Spotify took 150 days, then we can really see that is quite fast. So these are also really big services, and still ChatGPT, it got really big in a really short time. So yeah, clearly something is going on here. So what can all these LLMs do? So we have a couple use cases here. For example, you can do search. There's quite a battle now in the search space where big companies are competing with each other to implement LLMs also in their search engines. You could also do summarization, really compress a large text, get the keys features out of there to create a shorter text. Or for example, text generation, also useful for maybe people in high school, and then they can generate an essay for them. Yet you can also do, or classification, for example, sentiment analysis. Hey, what is the tone of voice or the main emotion in this text? You can also do that. But I want today focus on information extraction. So what does that mean? Say on the left-hand side we have a text. Given the text that follows, extract properties X, Y, Z. That is something we could ask the LLM, which is the parrot here in the middle, because it's very talkative. And then using the LLM, we can on the right-hand side get some structured data back. So what is this structured data? Well, YAML, JSON, CSV, anything that has a predictable structure to it. And then we could ask the LLM, okay, maybe we can grab that information right from the text. So what does this document, for example, look like? Well, here, for example, I have a house listing. This is a house in Amsterdam that's being advertised, and it has some properties here, like a price and the square amount of meters, and also a description. And that comes from a house listing website. This is a really popular one in the Netherlands. We have all these houses that are being listed, and people use this frequently to find their new home. But so actually, if we zoom in on this description, there's a really large piece of text, but what is inside this description? We can see, okay, it says here, there's a parking possibility, there's an elevator, there's a balcony facing southwest, pets are not allowed, sharing not allowed, students not allowed, smoking is not allowed. And all these things, when you're searching for a new home, that is potentially very valuable information to have. But yeah, it's hidden inside this large piece of text, so we cannot really use it to filter. And then you're searching for your home, and you really have to go inside the text to see, I'm a student, but this home is not for me. So then I can really read your mind, and I can already hear you thinking, can we extract these properties using a large language model? And so that is indeed what we're going to take a look at. Can we use these housing descriptions and together with an LLM to extract some useful properties? All right, so let's start with doing some prompts with the LLM. And we're going to start with a quite naive approach to then later get to more sophisticated approaches. And there I want to say a naive approach and sophisticated approach, it doesn't necessarily mean it's a well-performing approach or a non-well-performing approach. They're just naive and simple and sophisticated. So that we're going to take a look at. All right, so let's start with a simple prompt here on the left-hand side. Can you guys see it here also? Great. So this prompt, here we're, for example, saying, okay, a house listing will follow as it appeared on a housing website. Please extract the following information from the listing. Is pet friendly? Yes, no, or unknown. And then here we're using a bit of formatting. This is similar, to Markdown. So the LLM, it comes familiar to the LLM. And here we have this variable house. So what is that? That is actually this entire house description that we just saw. So we just copy pasted right into there with all these different things that it's saying were not allowed or allowed. So we pasted in there. So what does the LLM output? No, it's not pet friendly. Okay, well, simple trial. Let's make it a bit more sophisticated. So here we can also ask, okay, same thing, but provide us a quote so we get a bit more confidence in the output of this LLM. Does it make sense? Can we indeed find it back in the original text? And indeed here it can say, yeah, pets not allowed. It's stated there literally in the text. Okay, that's nice. But now, okay, let's see if we add a couple more properties. So a garden, parking place is suitable for a couple. So that will be a little bit harder property to extract. So it has a bit more reason. Okay, when is an apartment suitable for a couple? Well, then is there enough space? Or the LLM has to think a bit, so we can also try that. And does it have a balcony? And so here, indeed, you see it gives some nice answers about that. But then it's still, the usefulness for this is really limited. So we don't have structure. It's not a predictable structure here. It's just a bit markdown formatting. So we want a structure. So then let's see, how do we get this structure? How do we get the LLM to output a structure for us? So now we're doing the same thing. Here where it's the dots, that is actually us stating which properties to extract, which is the garden and the parking place and so forth. And here we are asking the LLM kindly provide the output in a JSON object. And indeed, okay, we get a JSON object. Okay, so that is nice. That is something we can finally work with when we're starting using Python to use these properties. But maybe we can actually bring back this quote. So previously here we just get the values. Maybe we want a quote. And actually here what we can do, we can just spell out an entire example JSON response. And then wherever we're putting dots, we want the LLM to fill in the dots. So indeed, oh cool, you can see the LLM, it's filled in basically the blanks, and also quote now is back. That is cool, but if it doesn't find the quotes now, just outputting a dash. So we'll have to parse that dash. That's not very predictable. We're gonna work with that later. So now this JSON object, that's nice. So we can put it actually in a JSON.loads Python function. So that is nice. But what if I change actually the input of this this house? So previously we had a nicely formatted description of a house. But now, for example, we have a description of a house. It's super minimal, almost no information. For some reason, the real estate agent, they didn't fill in this description. And then what is then the LLM prone for if you give it way too little information? It is then prone to hallucinate. So here actually we just ask it, okay, extract these properties from this housing text, but there is no housing text. It completely makes up just a house on its own. So it's saying, okay, this is a beautiful modern house. It's located in 123 Main Street, Anytown, USA. Just a completely non-existent street, and then it cost $500,000, and that is just nonsense. But even the worst part is this is our output, is this string here at the top. So for some reason it just didn't have all the information that it needed, and even just put a bit the string at the top, and that is really problematic because it's no longer a valid JSON object. We cannot even parse it anymore. So then here, okay, what can we do now? There's a couple ways a bit to mitigate this. So this can happen. So if you're using this really on a large scale, and then there are going to be examples like this. So either if your LLM you have a temperature set to a value higher than 0, maybe you can just run it again. Okay, see if it does it provide a different output. Or maybe even we have this nice error here, where actually it's describing, okay, why it cannot it parse the JSON error. We can also prompt the LLM again and just show it its own produced error. So it's basically, okay, you just produce this for me and just show it back to the LLM. Okay, try again. This is the error that I got, and maybe it can do better the next time. All right, so let's go back to this working example. And then actually a next question pops up. If we're going to do this for many houses, and then we can see, okay, all these values, does it have a garden or a parking place? If we're going to do this for more houses, and if we want to be able to trust whatever the LLM is generating, we also want to do some type of evaluation. Because otherwise we're just completely blind trusting whatever the LLM produces. And we want to be able to a bit check, okay, how well is this LLM in extracting all these properties for us. So here we can say, okay, once we are inside the Python world, so we just parse this JSON, maybe we can compare this output with some ground truth. So how does that look like? A very simple approach, not even considering the quotes, is really just to compare these values, and then we can see, okay, how many of these properties did it correctly extract. Well, in this case, it got 60% right, and that is taking into account both the actual value, does it have a garden, yes or no, or did it appear in the text. So that is also what we're checking. Did the LLM think it was in the text at all? If it's not in the text, then it doesn't need to know the value. All right, and so with that, if we run it enough times for some houses, we can actually do a bit of benchmark. So that is interesting. So here we're doing exactly the same thing, a bit the same prompt for some number of houses for GPT 3.5 and Palm 2. And that's nice. Okay, so if we want to solve this use case, and then we can get an idea, okay, which LLM works well with this prompt and which LLM can extract this information in a good way. So that is quite useful that we can do a benchmark like this. But for those who are really carefully looking at the slides, you can see in the legend it also says GPT-4, but it's not here. Where is GPT-4? Well, GPT-4 actually, we tried this and then it got 100% incorrect. So we're running this benchmark, just like, hey, what is happening? And we're using MLflow and then tracking it a bit, and then we can see, okay, these succeeded, and then here is GPT-4, and whoosh, everything failed. So that was weird. So we were like, okay, investigating a bit in MLflow, we log a bit. Okay, we use this prompt. This is the output. So what happened? It turned out that GPT-4 it was really talkative. So it really liked to get the proper conversation. So even though we just asked for only JSON, it's still providing a bit of text at the top and the bottom. We really only just need this one. So to mitigate that, either we do a bit regex and we extract this, or we can just ask, hey, GPT-4, return nothing else except a valid JSON object. Do not surround the JSON object with backticks or any other text. So really, this is really where the prompt becomes important. Only these small notices makes the LLM act differently.
Here's your microphone.
Did you really have to use a follow-up prompt?
Like another one, you mean?
Yeah, couldn't you put this in the first prompt?
Yeah, it was just rerunning the entire thing with prompts. We don't really run like a second prompt with the information of the first.
Thanks.
It was just
yeah
rerunning with a different prompt altogether. Yeah. Yeah, good question. Thanks. All right. So indeed, now we get GPT-4 in the benchmark as well. So it's a bit in the middle here. So that is cool. But actually, can we do better? So now we just went the route of giving the LLM an example of this JSON scheme and then putting in some dots and then saying, okay, fill this in for us. But other ways to do this. So let's see. Okay, this is a JSON example, but maybe we can do something else. Maybe we can actually define some pydantic model, and then maybe we can print out a really elaborate scheme of what we want to extract. So say, for example, we have this pydantic model, and actually we can instruct pydantic, okay, print out your entire scheme in a JSON object. So here on the right hand side you can see it's quite big, but it's really containing many kind of elaborate details. So this property, it has to be of type either a string or a null. This has to be a boolean or a null. And then really all the intricate details are listed there in the scheme. And yeah, pydantic schemes, they should come familiar to the LLM because then it has knowledge about all these things that exist. So maybe it can work nicely together with a pydantic model. So let's try that. So here we have the same prompt, but then here we're putting in this this template, which is our pydantic scheme, and then again the house listing. Let's see, what does it return? Okay, quite nicely. We get again a JSON object, and then really the additional advantage here is then we have defined this pydantic model, which we had defined a scheme for. It should output the JSON which is compatible with this pydantic scheme. So now we can also load it back into our pydantic model. So that is pretty nice. So we can go like right back into the Python world without this JSON.loads. Like we can be more confident if that function succeeds indeed, we get the right structure back. So that is useful, but what is the performance? So that is in the end what matters. And here we can see, okay, GPT 3.5 is doing slightly better, GPT-4, okay, also, and Palm, it actually does worse. So this is really where you can see, okay, all these LLMs, they were trained in a really different way. They are completely different models. And yeah, providing really this very detailed amount of information in the scheme, it doesn't per se mean, okay, it's going to perform better. It really differs per model. And you can now see, okay, on the right hand side, we have some space left. So can we do even better than this? So let's take a look at that. So this is specific to OpenAI, which is called function calling. So what does function calling do? Function calling, it was quite recently introduced, so June of this year. And what function calling aims to do is to create a nice gateway for you to execute functions after getting the result from the LLM. So a typical use case, for example, would be exposing some functions to the LLM, maybe get the current weather, or do some Google search, and then the LLM can choose for itself, okay, I want to call this function because I require this information, and then you can call the function for the LLM, because that is something the LLM itself cannot do, and then you put it back in the chat again. But maybe we can also use this same functionality, this function calling, but then to extract actually these properties from a text. So let's see about that. So now we get a bit more specific into the code. So here we are starting a new chat completion with a GPT 3.5, where we're here actually listing, okay, these are the functions that you have available. You could call these functions if you want. And this functions object is really a list with a really specific scheme of, okay, how does this function look like? Really, okay, these are the parameters in the function, and they should be of these types. This is the description of these parameters. And in that way, the LLM is aware of the function that you made available for it. And then it could call it. Even, we are actually here defining a function call, which is forcing it to call this function. So that is useful functionality for us because we just care about extracting really this structured information. Okay, so let's try that. So now, because actually we are calling this function, everything that LM does, it has to go, through this function. Like its output has to be of a format where it's calling this function. So the only thing that we've need in the prompt is actually the house text. So we just put the house text there, and as a context we can actually slightly change the context. We can actually point it a bit more towards its task, which is that it's an assistant, is a large language model designed to extract structured data from text. Okay, so let's see what happens. So again, we have this chat completion here, and then as an output, it's saying, okay, I want to call this function with these values. So the values that it's going to call the function with is pet friendly, has garden, has parking place. And that is exactly the information that we desired to extract. So that is nice. And now again, we can load that JSON object in a Python dictionary, and then we can call this function. That is really nice. So we have now a really a strict interface that it has to go through this function, and the LLM is fine-tuned for calling these functions as well. And even the last part where what we're doing was actually loading in this JSON object and then calling this function. There's even a library for you. I would say it's a bit extra juice if you're really getting into this. It makes your life just a little bit easier. And what it does is you can actually, again, instead of defining that really large JSON file describing the function, you can again define a class where you're actually defining also the properties that you want to extract. And then you can print the schema that before we had to generate this entire schema ourselves. Now you can generate that schema from that class. That is pretty nice. And there, we are now doing the same chat completion, and then we can together with this library we can extract these properties. So that is a useful shortcut if you're really doing this in more times, and then you can use this shortcut library. It comes in useful. And then again, we can go into Python world. It will again be this object called house features. So that is nice, but how does it perform? Again, function calling, and this is where it gets a bit odd. So we got really enthusiastic about all this functionality, and we can really force it inside this function. But we can see GPT-4 is performing around the same as before, and GPT 3.5 is performing even a little bit less well. So this is really where we're coming back to the point that we have this bit naive approach, just provide like this entire JSON example, and then we provide a schema, and then even a function interface that it has to go through. Here we can really see, okay, it depends per model, it depends how you design your prompt. It really makes sense to try out different things if you really want a performant use case out of this. All right, so now what? We saw all these three different methods. So what did we actually do? So let's conclude a little bit. So yeah, this was cool because we have this data set where we're, for example, listing a house. Yeah, we can add some new properties to it, which we extracted using the LLM. Does it have a balcony? Is it pet friendly? That could be potentially very useful if you have data sets lying around with all that information that is currently hidden, extracting it, and then working with it. Because it's structured data, we can filter it. You can do all these operations that you previously couldn't do. So we saw three methods: providing a JSON example, providing a pedantic schema, and even using OpenAI's API, which is function calling to extract that information with varying performances. So if we conclude using LLMs for dataset enrichment, it is good if you provide explicit instructions. So remember where the LLM, it started surrounding the JSON with its own text. Yeah, you have to be really explicit and instruct the LLM exactly what it should do. The output format is explicit, so you're going to ask it to provide me in a JSON in this format, and that is what I want as an output. The input data is comprehensive, so if your house descriptions, if they're super short, then the LLM has little data to work with. It might start hallucinating. That's not nice. And also, if the data is valuable enough to justify cost. So these are really powerful models. So you have to ask yourself the question, okay, is the data indeed of a certain complexity that I need an LLM to extract it? Can I not use a simpler method? So okay, if that is indeed the answer is yes, then you can weigh the cost against the benefit. So these properties, if they are valuable to you and you want to use them later, then indeed maybe it can be a very good option for you. Do also exploit structured output possibilities. So JSON pedantic, they can really help designing your prompt, getting that information out of there, and also function calling if you are using GPT. And in that case, the LLM, it loves the house searching world. So that is good. And then also, I'm quite curious, what is your use case? So you listen to all of this, maybe in your mind, you're already thinking a bit about what is shown on the TV, and then also, okay, maybe how can I use this? I'm also curious about it. So if you have an idea, and then come and tell me afterwards, that would be nice. And then for now, I would really like to thank everyone.
There is some time for questions.
Yes, thanks first of all for the very interesting talk. I was wondering about the cost of these. Like, for example, here you had 100 samples for each test, I think. What does it cost to shoot 100 samples? Do you know?
I didn't measure it, but the cost for this was still relatively low. We really focused on creating a nice experiment, seeing what works well and what not. So we didn't run it through the full data set yet, because our full data set is really the Pararius housing website. The data set is like thousands of houses. So there, it's a really interesting question also for us to explore.
Yeah, but it's relatively low, like some 100 euros, or do you have any? Yeah. I mean, depends on the company what's relatively low cost.
This,
I guess. Yeah.
exactly, yeah. You're right indeed. Yeah, it's really below 100. So
okay.
yeah.
All right, thank you.
Yeah, thanks. I have a question if you have any ideas how to clean up the dataset later a bit, because a mean score of 0.5 or 0.6. Are there any quick things you can do to even improve that without the LLM? I don't know. Or like similarity detection of the quotes or something. I'm doing similar things with a job ad dataset, so just want to clean it up a bit.
Yeah. Okay, so the cleaning before you hand it to the LLM,
No,
right?
the
Or
output from the
afterwards?
LLM, so you can filter out a bit of the hallucinations and stuff.
Yeah. All right. Yeah. So in this case, these hallucinations, like the example that I showed, it didn't parse at all. because it just provided this extra string at the top, and then yeah, the output that it would generate if it didn't, if it did parse, if it didn't do this thing, yeah, there you would have to yeah, do some checks, or maybe you can yeah, already be a bit careful if your description is super short. Yeah, in these samples we were kind of aware which samples we were putting in, so we knew, okay, this one is one with super small description, and the other ones had a larger description. But yeah, that's really why I'm also yeah, stating, okay, do experiment, and then we're putting all these plots together, because yeah, this is like generally in AI a thing, right? Can we trust it? And then especially with LLMs, before you start really using it, okay, do explore around what works well, what is it outputting.
Thanks.
So this is a little bit also the same question, but can you tell in the prompt not to hallucinate? So can you say, if there's no description, don't give me an answer or something like that?
Yeah, yeah, okay. So what could you put in the prompt such that you do you want to get warned about when it doesn't have enough information, or
Yeah, I don't want false information. I mean, 0.6 is okay if it's an enrichment, but if that means 40% is totally made up information, I don't want it.
yeah, yeah, indeed. Yeah, I think it's a good question. So I didn't try to fight the hallucinations here yet. I just observed it, but I have some colleagues also, and they work on a use case where it's also quite important. Can we trust the output? And then they're yeah, putting something in the prompt which is saying, okay, if you have too little information, just don't proceed at all. Just yeah, state that like in the output that you didn't have enough information, and then you can a bit prevent. Okay, like it has a little information. It's just gonna try its best to put something there anyway. But yeah, you can put something smart in the prompt, and then you can also say, okay, yeah, this just doesn't work at all. Yeah.
And did you try with a small amount of information? Did ChatGPT 4 also hallucinate there, or is it just 3.5?
Not sure. The example was, I think, with 3.5.
Yes.
Yeah.
Thanks.
Yeah. Thanks. Good question.
One more question.
Hey, nice work. Did you try it in Dutch?
Yeah. Okay. That's a good question. That we provided it all English text. That is actually, yeah, it's really one of the things we also want to explore. So different models, different prompts, also on different languages, because yeah, these models are known to perform differently on the different language set. So yeah, the short answer is no, we didn't try with Dutch, and the other answer is we're really interested to do it.
Yeah, so
Yeah.
my experience is if you give it a nicely grammar text, then it will be all right in English. But we are in the medical field, and people don't write nicely grammatically correct, and then you get very strange results.
Mm.
But
Yeah.
that might need for you use case, it might not be a problem.
Yeah, and what would be a strange result? Like, why is it so strange
It
for you?
doesn't recognize it, so it doesn't give anything.
Yeah. Yeah. Okay. Yeah. Yeah, indeed. I'm here like really good suggestions here. Some that I already thought about, and then the others. Yeah, it's good to extend this experiment. Yeah.